Hello everyone, my name is Anishana and today you are watching Docker web series. As of now, we have successfully completed our sixth topic. If you have not watched the previous videos, then you may click on I button. Today we are going to cover our eighth topic, that is type of network in Docker and how to create and use it. Just for your information that this PowerPoint document can be downloaded from my GitHub page. Beside this, subtitle for different languages such as English, French, Russian and German is available for this video. Today we are talking about network, so I will talk about only network related topic. If there is no container created on host machine, one can notice that Docker interface status is down. However, this status will change to up when you create your first container. We will check Docker 0 interface status in our lab. So let's do the recap. In step 1, we created a VM with the help of VirtualBox. In step 2, we install the CentOS 9 operating system. After that, we remove the old containers engines such as Docker, Podman, and Build. Then finally, we install the Docker engine on the top of CentOS 9 operating system with the help of yum install docker command. If you have not watched these steps, then I recommend you to press the I button on the topic right hand side at the top here. Further, we have created one container with the help of docker run container run command, and right after we install the Apache 2, vim, curl and e-link packages. Instead of installing the packages as it takes some time, this is the reason I'm using my image which has all the packages pre-installed that I created in my previous video, Docker file video. This container get the IP address from the Docker engine, and we can check the IP address with the help of Docker container inspect command. Our topic is publish container port to host. Let me explain with the help of diagram so that we can understand better. First, we have a window machine and it has IP address 192.168.1.10. Then we create a VM and install the operating system, and it get the IP address from my DHCP server, my Wi-Fi router. Further, we install the Docker engine and then create a container and bind the host machine VM port 3901 with container port 80. In Windows machine, if we open a web browser, we must type http colon slash slash VM IP address colon 3901 port number, because my host machine do not have the information of my container IP address, and we bind all the container traffic with port number 3901 in and out traffic on Docker host machine. Same for container 2, and it is bind 3902 port number. Before assigning the port number, it is good to test if this port is already used or not. So here 1.19 same IP address of my VM and then followed by different port number 3902. So what command we can use to bind this port number? Option is -p 3901 colon 80. So let me explain all the commands. So container is my management command and run is my subcommand. I stand for interactive, T for terminal and D for detach mode because I don't want to go inside this container, and hyphen hyphen name container name. So this is the name of the container that we are assigning. -p stands for publish a container port to host, and 3901 is my host port and 80 is my container port, and my web server 1 is my image that we used. So all the commands options you can see here. So let me create one container first in the lab environment and I will show you how to access it. So I have already logged in into my Docker machine. So let me check if any container is running or not. As I can see here that there is no container running in this Docker host machine. And here, if I execute IP A, I must see that state is down here. That I mentioned in my previous slide. If there is no container running, my Docker 0 interface showing state down. So let me create one container here and my web server 1 image that I used. So, so let me clear the screen here. And as you can see here that container 1 is my name, and here I'm binding 3901 port number with this container. So now my container is working fine. So I should see my website http colon slash slash 192.168.1.19. I should write here 19, right? This 19 is my VM IP address, right? As you can see here that 1.19 is my VM IP address. So let me hit enter, and here I can see here that I'm running this website on Docker container 1 Ubuntu OS. Same thing, I will use the same command here. So let me create another container with container 2, and here this time I'm using 3902 port number. So let me go inside this container, container 2 and bin bash. Let me go to inside this directory container 1, and then and as you can see here that it is written here container 2, so I'm just overwriting here to container 1 to container 2. Now you can see here that it is container 2. I did the configuration changes, so I need to reload my server Apache 2. So let me reload this here. So now this web server is running on. Let me copy this and paste here and 2. So now you can see here that Docker container 2 is running. So this is what we have already covered in this PPT. Let me switch to my previous diagram where we had only one container created. What we did in our lab, we used our image, my web server 1, which was built on the base of Ubuntu operating system and Apache 2 package pre-installed. So both the container get the IP address from my Docker engine. It means both the containers should pingable to each other. So let's check if it's pingable or not. So how to identifying the IP address? So the command is docker container inspect and then container IP address, container name and grep minus I IP address. So here I can see here that okay, so I need to go out and then execute this command, and here I can see here that my Docker engine assign 172.17.02 IP address, and what other container is getting the IP address, that is 172.17.0.3, and both the container get the IP address from Docker 0 interface. So if I use this, as you can see here that 172.17.01. Okay, so let me ping. So there are two ways to ping the IP address. The one is to ping the container 2 IP address outside from the container 1. So like this. So I'm still in the host, Docker host prompt, and if I press enter, I will get the response that yes, I can able to ping this IP address. The other way is that go inside this container bash and ping this IP address. Simple. Okay. So same thing, I can check for container 2. So am I able to ping the container 2 IP address or not? So let me use 2 here. So yes, I can able to ping container 1 IP address from container 2, right? So the other test we can execute here, that let's ping the container 2 from container 1, but this time not by IP address, but this time with the name. So if I press enter here, I should get the error prompt here. Yes, because DNS is not able to resolve this container 2. Same will happen if I try to ping container 1 from container 2, whether outside or from inside. It will not work because the default bridge driver. Don't worry, we will cover what is default bridge driver in my coming slide. So let's jump into the network drivers. How many types of network drivers are? So they are bridge, custom bridge, host, none, overlay, Macvlan, Ipvlan. One of the main reason that Docker container and services are so powerful is that either you can connect them together or connect them to the known Docker workloads. We can manage the networking of containers with the help of network drivers. Although there are many network drivers available for Docker engine, but we will talk about most common used drivers. For an example, none, host, bridge, custom bridge, overlay, IP VLAN and Mac VLAN drivers only. So these are the network drivers, and here is the name. So we can mention any name here. So, and as you can see here, that bridge, host and none, these are the three drivers which are by default. When you install the Docker engine, you will get these three drivers. So none, host and bridge network drivers. For other drivers, we have to manually create it. As I said previously, one can execute one command docker network ls and observe the output like this. So these are the driver, and the same you will see the name. So what is Docker networking? So let's deep dive what happened when we create a container in the Docker host machine. First, we created the VM and then installed the CentOS 9 operating system. After that, we configure the IP address of our VM so that we can connect to the internet. Before creating the container, we must install the container engine. We use Docker engine. So this is my IP address of the VM and this is my Docker engine. When we install the Docker engine, we must see new interface called Docker 0. This interface will be the gateway for all container by default. It means when we create a new container, for an example container 1, one can notice three parameters in terms of network. Container 1 IP address which get from the Docker engine. Gateway must be Docker 0 interface IP address. Further, you will observe new interface called worth here, which is pointing to Docker 0 as a main interface on the host machine of the VM. Same thing happen when we will create another container like this. In short, we can say that whenever we are creating a new container, a new sub interface will be created in the host Docker machine. So our agenda is what is none driver and where we can use what is host driver, and where we can use what is default bridge driver, where we can use simple, and how to create and delete the network drivers, difference between default and custom bridge drivers, what is IP VLAN drivers and where we can use what is Mac VLAN driver and where we can use. So this is the agenda of our video. So I hope now the basic networking you understand, and now we will go in deep one by one we will cover. So none network. So let's start with a very simple network driver, that is none network. This network will totally disable the networking stack on a container. It means that this mode will not configure any IP address for the container. This is the reason it does not have access to the external world. Option that we can use in the command line to enable this network is hyphen hyphen network, or we can use only hyphen hyphen net. We will use both option in the lab section. And where we can use, so it has the loopback IP address, thus we can execute any batch jobs in the container, right? So this is the use only what I know. So let's go to the lab for network driver, how we can go. So let me go inside my server. Let's check if any container is running or not. So yes, there are some containers running. So how I can delete all the containers with the help of a single command, that is container lsaq. So it will print only the container ID. So I'm just going to delete all the container ID. So now refresh the window and check if any container is running or not. So now we have already checked no container is running. And how I can check the networks, so as I said previously that there are three network drivers available by default. So all these three are none, host and drive and bridge network. So first we will going to learn none network. Okay, so let me create a new container. So as you can see here that I use hyphen hyphen net none, and I'm just giving the name none container one and use my image. Okay, so let me go to another container here, container 2, and here I'm going to use network full name, right? So as you can see here that it is also created. So let me inspect this container. So when I execute the command inspect and none is the name of my none network. So I just use none here, and as you can see here that none container 2 and none container 1 both is configured and attached with this net. And as you can see here that IPv4 address is null here. So let me verify. Let me log in inside this container. So as you can see here that I'm inside this container, and if I execute ifconfig command, and I can see here that no IP address is assigned by the Docker engine to this container. And yes, I have seen some, I can observe one loopback IP address so that I can log in inside this container and execute some batch jobs. And if I execute IP root, I see nothing. That's it for non network driver. Let me exit from here. So let's proceed for next one, next network driver. So our next driver is host network driver. So what is host network? So Docker host network is also called as Docker network host. Just change the name from host network to network host. And it is a default network driver offered by Docker engine. One can use host network if we don't want to isolate the container's network from the host machine. It means container will share the host network stack, and all interface from the host will be available to the container. No extra IP address will be assigned to the container, and no port need to be defined at the time of container creation, because same port is used what we define in the host machine, right? What are the use case of the host networking? So where we need performance improvement, because it does not require NAT, network address translation. In production we use seldom this network driver. The host networking driver only work on Linux host, and it's not support on Docker desktop for Mac and Windows, and for Docker EE for Windows Server. This is just for information. Let's proceed for lab, and here I'm coming. So I have already logged in my machine in the previous section. So let me clear the screen for you. So again, I'm just going to execute network docker network ls command to show you that we are using the existing bridge network. So before creating any container, let me inspect the host network driver. And as you can see here that the container field is empty because we have not created any container yet and also not attached newly created container with this network driver. So let me create one new container here. So clear the screen. So Docker container run itd net host. So here I'm using net host and the command and the name of the container is host hyphen container one and using the same image that we created. And this time if I inspect this host network, I will see that container is attached. Host container one is attached with the host network driver. One can notice that no IP address is assigned to this container. So let me log in. Let me go inside this container, clear the window, and let me go inside this container. And then I can use ifconfig. So this time I'm using IP space A all. And here you can see that my VM IP address is showing inside this container. So let me go inside this container so that I can show you how to check website and modify the index.html to docker host network container. So this will I will see. As I said previously that if we do any modification, I have to reload the service. And now I'm going to exit from the container and let me curl use the curl and localhost. If I execute localhost, I will see here docker host network container one. This is what we modified, right, in this command with the help of sed -i. So now this time I'm going to create another container that is container 2 and use net host same. So it is created and you will notice the container will be on exit status. So let me execute the command docker container ls -a host and I see okay. So let me use this host. So now you can see here that container 2 is an exit status. Why? Because both are of using port 80 and we have already assigned port 80 to container 1. So this is the reason Docker engine stopped this container. So let me check the log messages for container 2. So this is the command that we can use option container logs host hyphen container 2, right? So it will show you. So now you can see here an already address already in use could not bind to address blah 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 to port 80. So this is the reason no listening socket available and I'm shutting down this container. So log is also important. So you can use this option. That's it for the host network driver. Let's proceed for next network driver. Our next topic is default bridge driver. So generally when we create a container without specifying the network driver, it will attach your container with default network driver, that is bridge network. So let me create a one container and specifying the port like 3901 and the container name is container 1 customer 1. And here I'm not specifying any network. Okay, so if I press enter in the command, we haven't specified the network driver option. It means that the container 1 will attach to default bridge. Customer 1, yes. So as you can see here that it is getting the IP address of 02, and let me create another container with 2 and increase the port number 3902. So as I said that there are two ways. So one is to inspect the container and the second command is to inspect the network bridge. So if when you press enter, you will see all the information under container tab, customer 1, container 2 and container 1. So from there you can check the IP address. So I can see here that container 1 is getting 0.2 IP address and 0.3 is for container 2. Okay, so let me copy. So let me execute one more command here to check the execute container 1, customer 1, container 1, and I'm going to ping 03 IP address and count is 2, ping count is 2. So after successful 2 count, it will stop. Okay, so might be there is some. Okay, so maybe there is some typo. So 1, 2, and it's exit. So yes, I can able to ping the container 2 IP address from container 1. Okay, so please note one point here. If I'm trying to ping the container 2 by its name, it should not work. Okay, so let's check in the here, and if I press like this and remove 1 and press 2, replace 1 by 2, yes, I'm not able to ping container 2 by its name, container name, right? Due to the security reason, this default bridge network driver do not have the facility of DNS. In the coming slide, we will learn what option we can use to bind one container to one specific network driver. So this is the command we executed, container 1 and port number, and then container run IT again. We created the second container, and then container inspect container 2 IP address, and then docker container IT customer 1 bin bash, and we can curl this IP address. Okay, so now we are going inside the container 1, and there I can try to download the file URL. So let's continue to create another container for customer 2. Here I'm using customer 2 for customer QST2 for customer 2, and increase the port number of host machine. So let me show you in the lab here. Let me clear the screen first. Press some enter here, and now here I'm using CUT for customer 2, and I have also increased the host machine port number 3903. Again, I need to grab the IP address. So here I'm just checking the IP address is 04, and now login into the container 1, customer 1, container 1, and ping this IP address 04 of customer 2. So What I'm doing here that I'm just going to test the network path, or maybe you can say that ping result from container 1, that is for customer 1, and here I can able to ping this container. And further, if we log in into the customer 1 container and try to download the website, I should able to download it. Let me show you here. Bin bash and curl 0.4, and yes, I'm able to fetch the content of container 2. So it is clear that if we attach all the container with default bridge network, we can access to all container. So it means that one container can access to another container. They have full network reachability. So let's go back to our presentation mode. So here we inspect the IP address and then we try to ping the IP address from container 1 and we get the response. And further, we log in inside this container with the help of execute command, and then we did curl, right? And we get the output. So let me clear the screen. So how to separate the customer network? So it depends what exactly your requirement is. If you want to use VM or host machine IP address with different port number to access the container, then you may use custom bridge network. So this is a new custom bridge network. We will try to understand different situation when we process with another network driver. So let's start with very basic Docker networking. For custom bridge network, it is necessary to go with this visualization so that we can understand better what happens when we create a custom bridge network. So this is my VM, and which is having the IP address of 1.19. Okay, and then we install the Docker engine, and then when we install the Docker engine, Docker 0 interface is created and it get the IP address 172.17.0.1, and we created a test bridge 1 custom bridge network, and it is having the different IP range, that is 172.18. Again, when we create a container, it will create a new interface in the host machine worth, and if we attach with this test bridge, it will get the IP address 02 and get the default gateway of 01 of this bridge, test bridge 1 network. Again, when we create another container, it will create another worth interface, and it will connect like this. It will increase the IP address. So first container will get 02 IP address, second container will get 03 IP address. So what happen when we create another custom bridge network? It will get a different IP range, that is 172.19. And if we create the container and attach it, and it will again create a new worth interface, and these will get the default gateway is the test bridge 2 IP address. As you can see here, 19.0 19.0 is the IP address, and they will again get the new IP range here in this scenario. So you can you know connect to the internet if you wish. So we will check if this container 1 can communicate to container 1 or not. So if this container one is going to, ping this, or this container can communicate with this. So I believe that this will not. Let me remove all the highlights here. So what is, custom bridge network? So how to create the custom bridge driver first? So the command is very simple. Docker network create test bridge one. So here we can say that Docker Docker network create and then your custom bridge network name. So in our PPT, we created two test bridge one and bridge two custom bridge. And if we inspect this test bridge, we'll get that the subnet is 18.0 and the default gateway is 18.0 and subnet is this 17.0. It's a bridge and this is my custom bridge. So it is having the 17.0 and it is having 172.80. I just grab subnet. Okay, so let's move forward. So how to attach the container with specific network. So this is we have already learned in the previous slide, hyphen network and network name. So here I'm going to use network bridge one. So this is what we will do in our lab section. Don't worry. So when we create a new container, we should use hyphen network equal to custom bridge network name. So here we specify test bridge one to attach the container with specific network. So now we have two custom bridge networks. So we are creating two container under test bridge one network so that we can perform networking test. In this, we will going to ping the IP address of second container from container one. Further, we will ping the container two name from the container one. So last time when we used default bridge network driver, we were not able to ping the container two by its name, right? And after that, we will create another two container, but this time under test bridge two. So this is my test bridge two. Kindly bear in mind that we will using different host port machine port number right here. So again, we are just increasing the port number of my host machine because we have only one host here. So let's check the IP address assigned by the customer bridge network. So first container get the 172.18 series, whereas other container which is attached to test bridge 2 network get 172.19. In your case, it might be different because if you have already created some custom bridge driver, then you will get a different IP's range, right? So you need to check at your side. So what IP range you are getting here. So I'm just showing my side here. So if I execute docker container, execute test bridge 1 container, if config eth0 grep mask. So I can see here that my container is getting this IP address and this is getting this IP address. So there are too many ways, right? You can go inside the container or you can inspect the container from outside, from the host machine, or you can inspect the network bridge. So there are a couple of ways, right? I just try to elaborate all the options so that you can understand better. So ping test within the customer bridge network. So first we are going to test customer container one and container two. So at this time we have only test bridge one, and this is the worth I will show you in my lab. So let's proceed with some commands so that we can check the connectivity of container one and container two when we have only test bridge one custom bridge network available. So okay, so let me create the first custom bridge. So this is the Docker network create. test bridge 1, and we can inspect. And here I can see here that I'm getting 172.18, right? And here you can see here that in Docker 0, I do have 172.17.01 series IP address. Okay. So this is what we can achieve another way, that we can inspect the bridge and it is getting the 17 because it is going for Docker 0 interface. So, so let me create a one container, and this time I'm just using hyphen network test bridge 1, and the name is test bridge 1 container 1, and the port number is 3904, and create another container so that we can do the ping test with 3905 and the container 2 with under test bridge 1. So let me check here that what IP address I'm getting inside the container 1 as 18.02, and obviously for container 3, so for container 2 I will get 03 IP address. So let me execute this, and here I'm going to use ping minus C 2 and then container 2 IP address. Yes, I can able to ping this container 2 IP address. So let me clear the screen, and this time I'm just going to use container 2 name, if I'm able to ping this container by name or not. As you can see here that I'm also able to ping this name. It happens because we have enabled the DNS under custom bridge network. Due to the security reason the default bridge network, their DNS feature is not available. However, in the custom bridge network, the DNS is available. Let me go to the PPT session here. So as you can see here that container 1 and container 2 is reachable. So this is what we have done. So Docker container inspect, we get the IP address of container 2, and then we try to ping by IP address, and then we try to ping by the name, and both are successful. So this is the benefit of our default bridge network driver. So inbuilt DNS in the container. So if you check this file atcresolve.conf, you will see that 127.0.0.11 is the name server. So it will not available in the default network bridge. So let me show you here. So cat etc resolve.conf file. So as you can see here, this you will see that 0.11 is assigned here. And if I check Docker network inspect bridge, so I'm getting this IP address right, 172.17, and the customer one. So let me go inside this. So I'm just checking the DNS name is different, right? And in the default, the DNS IP address is same what we have in my host machine. And in the custom bridge network, the DNS is added here. 127.0.11 is added here. So now Let me create the another custom bridge driver so that we can go further for our network test. So here I'm going to create another test bridge 2 custom driver. And if you want to inspect this custom bridge driver, you will see that it will getting 172.19. So it is increasing, right? So 18 is assigned to custom, 18 is assigned to custom bridge 1, and 19 is assigned to custom bridge 2. And let me create a new container, and I'm going to attach this new container with test bridge 2. Same thing I'm going to here for, so let me increase the port number here. I'm sorry, I have not copied this command. So now for the comparison, I'm just going to check the test bridge 1 container 1 IP address here. And if I use test bridge 2, I will get 19. So this is what I demonstrated in my PPT. And the same thing is happening here, right? And if I'm trying to ping, let me go back to my ping command. And this time I'm going to ping this IP address from test bridge 1 container 1. I should not get the response. So let me show you here. As you can see here that the container 1 from test bridge 1 is not able to ping the other container. So that is good that one customer cannot see the traffic of another customer. This is what a security is achieved when we use custom bridge network. So ping test between two custom bridge networks. So this is what we get the IP address and then we try to execute the command, it fails. So you can use ping minus C to W3 and you will see that 100% packet loss. So same thing when we use the name, name is unknown. So obviously, let me show you here that the name is also not available here. So the DNS is working inside the custom bridge, not for the other. Let me show you here. As you can see here that this test bridge 1 custom driver do not have the information of test bridge 2. So that is good, and as per the security it should be there, right? So how to make a connectivity between two different networks? So obviously, yes, sometime it happens that I want to connect another customer network. So syntax is docker network connect and then network container. So the command is docker network connect test bridge 1 and then container name. So let me show you here. So here I do have no Docker network ls. So I have test bridge 1 and test bridge 2. So here I'm using Docker network connect subcommand and then test bridge 1. So I'm going to add connect this test bridge 1 this container name. So this is my container name. This container name is connecting to test bridge 1. So what will happen here? So when you execute this command, and let me show you that okay, now it should be pingable. So let me show you here that execute test bridge 1 container is going to ping test bridge 2 container, and this time I'm just using the name, not the IP address, and it should work. As you can see here that it is working fine, right? Why? Because I have connected this container with this network bridge, And let me show the IP address here. Move the window size and let me inspect the test bridge 2 container. As you can see here that I'm now getting two IP address. One is from 18 and one is 19 series. So this is the reason I'm able to ping this container from my test bridge 1 containers. So I hope this basic fundamental you understand why it is happening and why it is not happening. This is the IP address here, 18 and 19. Okay, let's move forward here. So how to remove the connectivity between two different hosts? So the same thing as connect and disconnect command. So let me show you here. Let me go back, connect, and then I just press disconnect. Disconnect this. And if I will now get the IP address of 19 series, it should say that unknown host. So DNS is the this container name. Name is removed from the DNS entry. And obviously I'm not able to ping this IP address, this container from container one. Okay, so difference between default bridge and custom bridge network. So default bridge network traffic allow between all containers. So maybe sometime it's a security breach if we have multiple customers container running on a single host. So traffic allows only its attached container. So it is clearly mentioned that attached container traffic is allowed. Can ping the container by IP address only, not by name, container name. Can ping either container name or IP address because of the DNS. There is no inbuilt DNS, so inbuilt DNS enabled by default. So these are the basic difference between default bridge and custom bridge network. So next slide is our next topic is overlay network. First, we created a VM and installed the CentOS 9 operating system. After that, remove the container engine packages and then install the Docker engine. Further, we created a Apache 2 container and it's get the IP address from the Docker engine. There are four steps we perform. Kindly remember these four steps. Till now, so far so good. What happens if this VM goes down? All the containers running inside this VM will also goes down, right? It means all my application will be down. For that reason, we need an extra VM so that I can spawn a second container as a backup or a secondary application on another VM or second hardware. Due to this, we need a connectivity between these two containers which are hosted on two different VMs. So this is my first VM and we have another four VMs. All these VMs we have already performed four steps what we discussed in our last slide. If we create any container driver on one host or VM, it won't be reflect to the second machine. This is the reason first we need to add them in a group. The good news is that Docker has a package that do this job, and the package name is Swarm. I will cover this package in my upcoming slide, but today we will going to enable the Swarm service and then create a network driver called overlay network. Now, now we can create an overlay network driver. So what are the benefit of overlay network? If we have multiple Docker daemon hosts and want to add all of them in a single network driver, we may use overlay network. The overlay network driver creates a distributed network among multiple daemon hosts. This network sits on the top of the host specific network, allowing container connect to it, including Swarm service container, to communicate securely when encryption is enabled. So container 1 can send the packet to this container 1 with the help of overlay network. So that sits here. So when it's go out, this is the overlay network. So it understand the CentOS 8 operating system understand it and it send it to inside. Whether it's 8 or 9, no issue. Docker transparently handle routing of each packet to and from the correct Docker daemon host and the correct destination container. So let's suppose if this container want to communicate to this container, so overlay network knows that this is my host 1 and I need to send the traffic to host 2, and inside this host 2 I need to send this traffic to container 1. This is the benefit of using overlay network. So initialize the Swarm service on master node. So the command is docker swarm init. That's it. So with the help of this command, we initialize the Swarm service. On the another host, how to join the Swarm cluster? The command is simple docker swarm join. Once it's done, you can create the overlay network driver on master node. Now the question is how to create a overlay network driver. The command is simple. Again, docker network create minus d overlay my overlay. So this is my, you can give any name here. So let's jump into our lab section where we will do all the subs. So this is my funny photo. So the I'm I'm going to create the first machine Docker 1 as a master and Docker 2 as a member of that cluster. So let me execute the IPA command here to show you the network configuration here. So I do have many things installed. So this is my 1.19 and the same as IPA. Here you can see that my IP is 1.2 and I have already installed the Docker package in this so that we can perform the Docker overlay network lab without any hassle. So to so here I'm going to disable the firewall first on both the VMs and the password is set hat. Why it is asking me? Okay, I'm not in root. So let me switch to root here. Okay, so let me execute this command again. Here I'm going to execute and disable the firewall. So after the reboot, it should be disabled. So let me check if any container is running or not on both the machines. Yes, there are multiple containers running. So okay, I need to remove all these containers, and here are some other containers are running here. Okay, so let me remove all the containers. The command is simple. I have already used many times, so I'm not going to explain this command again. And Docker network ls, here you can see here test bridge, nothing else. So let me execute the same command here, Docker network ls, and here I can see here only three commands. So let me execute here. So bridge host none and test bridge 1, test bridge 2 that we created previously. So now I need to, so I'm just going to create swarm service initialize, init for initialize. And as you can see here that to add a worker to this swarm, run the following command. So I'm just going to copy this command and paste it over here. It's very simple, isn't it? So now let me execute this command here, Control L and then Shift Enter. And here you can see that one new network bridge is created, Docker network bridge here. Same thing will happen here. Let me check. Docker Swarm bridge is added here. So the communication between Docker Swarm bridge and Docker Swarm bridge will be happen, right? So my first machine is my master and the second is the worker node. So if I execute docker node ls, here I can see here the start button. It says that it's a leader, and docker2 is my machine name of this. As you can see here, docker2. So let's go further without wasting a single time. Let me create a overlay network here. So docker network create hyphen hyphen opt is encrypted. I can use encrypt minus the overlay attachable. It means that I can attach any container with this overlay network, and the name of this overlay network is my overlay. So you can name it anything. So let me execute the network. So my overlay is created here, and as you can see here that it is saying that scope is swarm and the driver name is overlay, and the name of this driver is my overlay. So far so good. It's very easy. So now let me create a new container here. Here I'm going to create a new container, and the name of the container is overlay hyphen container one so that I can understand. And hyphen hyphen network is my overlay network. So it will attach to this network, and it will use my web server one image. And same thing I'm going to apply here, but so this time I'm using container 2. So now I'm going to ping one container to another container and it should work, right? And this time I'm going to ping by name from container 2 to container 1. Okay, I just pasted the wrong command here. So here, so this time I'm going to ping this container 1 from my container 2. And here I'm using the name, not the IP address. And here you can see that I'm getting the response, and both containers are hosted on a different VM. And same thing you can achieve here. And ping container 2. Here I'm getting the response. So it means that With the help of overlay network, we can communicate between different VMs. Next topic is IPVLAN. IPVLAN is another network driver that we can use and create in Docker engine. So this IPVLAN driver gives us, user full control over both IPv4 and IPv6 addressing. It means that user has control of layer 2 VLAN tagging and even IPVLAN L3 routing for users who are interested in underlay network integration. This is the reason IPVLAN is a true network virtualization technique. We can understand like this. For other network driver, we use sub interfaces called worth. In IPVLAN, we attach the container directly to the Docker host interface such as ETH0 and so on. So this is the small theory for IPVLAN. What is this IPVLAN? So in this, we are directly connect the container to the main interface of our Docker host machine. So let's do the lab where you can understand better. So I've already logged in into my machine. Let me show you here. So here we have the master machine is Docker 1 and the worker is Docker 2. So let me check if any containers are available. Yes, there are some container created here. So I don't think so that they will create some problem. But let me remove all the container first so that it won't be create any hurdle for me. And here let me show you my IPA. So here my interface is main interface is ETH0 and that is having the IP address of 1.19 and here IPA and here I can see that I do have 1.2. Okay, so let me clear the screen for both the terminals and let me check the gateway. Root minus n is the command and as you can see here that the destination is 192.168.1.0. It will go this gateway 0.0.0 and at the end 0.0 gateway is going towards 192.168.1.1. So this is my gateway and this is the gateway of ENP0S3, right? And this is the IP address. This is the interface and here my IP address is 1.19. Same thing I can achieve here. We can check here root n. I do have the same gateway for the both the VM. So it means that I can use the same command for gateway options. When we're going to create a IP VLAN driver, we can identifying different things like D is IP VLAN. So as of now, Docker network create and D is for driver IP. I'm going to create IP VLAN driver. And here I'm going to use subnet 192.168.1.0/24. It means that my container will get the IP address from this subnet and all the containers will have the gateway is 192.168.1.1. So here I'm manually bind that all the container will have the gateway of 192.168.1.1. And the IP range here I can also mention the IP range here. It's optional. So here I say that 1.40 and /30. So it will get the IP address of 140 and 40, 41, 42 like this. And minus O is option IP VLAN mode L2. As I said in my previous slide in my PPT that we can use L2 and L3. So here I'm using L2. So this is an optional. If we do not mention any label here L2 or L3, by default it will go for L2 and minus O is parent. My parent interface name is ENP0S3. So this is my parent interface that is I'm going to show, and this is my IP VLAN 1 name. Okay, so here I have just created here, so network ls. So here you can see that IP VLAN 1 is created and the driver name is IP VLAN. It's local. Let me clear the window here and let me inspect. So let me increase the window and inspect IP VLAN. Here you can see here the gateway is 192.168.1.1 and the IP range that we have assigned. So this is the configuration that we have mentioned in my command. So let me show you my the command. So this is the configuration, right? Options. So you will see here, and the parent is ENP0S3 and the IP VLAN mode is L2. So these are the options O, and this is O. Okay. So I hope it is clear for you guys. So let me create two containers so that we can do the ping test. So here I'm going to use hyphen hyphen net IP VLAN 1 and IDD. I don't want to go inside the container, and name is IP VLAN host 1 container 1. IP VLAN 1 H1 host 1 and container 1, and I'm using Alpine image. Intentionally I'm using a different image, otherwise you will say that I'm just going to use only my image, maybe it will not work. So Alpine you can use also, and same H1 S2 H1 C2, sorry. So let me inspect again IP VLAN network, and as you can see here that I'm getting the IP address 140 and 141 because I mentioned the range /40. Okay, and all these containers will have the gateway is 192.168.1.1. So let me show you the IP address again of ENP. My main interface is 1.19. So the IP address is 41, right? So let me add here 41. Am I able to ping? So here I'm going to ping my C2 IP address, container 2 IP address from container 1, right? I'm not going to inside this container. I'm just going to, ping, execute this command outside, right? So here I'm getting the good response. Am I able to ping my VM IP from this container? No, I'm not able to ping this. So this is the good thing, right? So my IP address is 19. It is not pingable. Okay, let me check my default gateway. If I'm able to ping my default gateway, yes, I can able to ping my default gateway. That is good. Am I able to ping my second host? So what is the IP address of my second host? Let me show you all these command is 2, right? 1.2. Yes, I can ping my second host. So why I'm not able to ping my VM? So this is the expected that I'm not able to ping my host machine IP address because it's jump directly, jumping and go outside. So this is the reason I'm showing you here that 1.2 I'm able to ping. Container IP address is my container is able to ping my VM IP address, not the container IP address. So container 2 is a different VM, so I can able to ping. So it means that my container can communicate to external world directly, and it goes direct. Same thing we can do here for the host machine. Same test we will do in the host machine. in the worker mode here. Let me remove all the containers first and then create the container. Sorry, create the network. Here I'm using again 1.0 and here I'm going to use 50 subnet and the IP VLAN same name, but this is a different host name, so I don't have any issue with that. Let me inspect this network IP VLAN. Here we can see that 1.1 is my gateway. This is the configuration option and this is my normal options. Let me create two container here. So C1 and C2, I just created two container and both the container is attached to IP VLAN 1. And here if I inspect this network again, you will see that they are getting 148 and 149 IP address. So let me check the IP here 1.2. I should not able to ping. So what are the IP of my container? 40, 40 and 41, right? So these are the two container IP address that I'm looking for. So 41, right? So here I'm in host 2, container 1. I'm going to ping 41 IP address. Yes, I can able to reach the host 1, container 1 IP address. Am I able to ping the IP address of host 1 machine, that is 1.19? Yes, I can, but I'm not able to ping my host machine. So the IP is 1.2, right? So 1.2, so this is the IP address I should not able to ping. Yes, you can see that it is blocked. Actually, it is not blocked, it is dropping, but it's jump from this network interface. So as you can see here that all my container is having the IP address of 192.168.1.19, and if I use IPA, you will not see any worth. So worth is different. So this is the different. I created two container and I do have only worth here. It's a Docker GW bridge. So it is Swarm interface. When we initialize the Swarm service, so this sub interface is interface created. So it is not related with the container that we created under IP VLAN. Okay, I hope you understand that where we are going to use IP VLAN and overlay network. So overlay network is when we need to attach two or three host machines. So we use overlay network, and when we do more modification or maybe connect the container direct to the main interface of my host machine, we use IPv4. So I hope it is clear for you now. If you have any question, please comment and I will try to answer. So our topic is Macvlan. Some application which monitor the network traffic require direct connection, which means we should have a unique MAC address. As per the official documentation of Docker, in this type of situation, you can use the MAC VLAN network driver to assign a MAC address to each container's virtual network interface, making it appear to be a physical network interface directly connected to the physical network. Although all the functionality of IP VLAN is adopted by MAC VLAN. In MAC VLAN, all the containers will have dedicated MAC address for outside world. This is the reason practical of MAC VLAN is not necessary here. Thank you. Please like and subscribe to my channel and press the bell icon to get new updates.